Hi guys, Nicole here with another tutorial. Today we're going to be talking about offset binary formatted data. So if you're new to it, if you're not sure what we're talking about, then you are in the right place. So let's go ahead and get started. So to begin, what exactly is offset binary? Like, I know the first time I heard this, I was like, what is that exactly? Well, basically, offset binary is a way it allows you to represent positive and negative numbers. That's all it is. It's just a formatting scheme that allows us to represent both positive and negative numbers. And we're going to look at how it does that today. And before we even get into that, so why the need for positive and negative? Why is that even a thing? Like, why do we need positive and negative numbers? Well, if we take a look at here's a good example. So if we take a look at this Cartesian grid right here, so you might remember this from school. Hopefully you remember this from school. This was one of my favorite things to do back in school. It was like connecting the dots. So you can see, like, if we were to put like a dot, like say right about approximately right there, that dot is going to have an x and a y coordinate. So its x value will be, so again, now this is our x coordinate here, and this is our y coordinate over here. Like vertically, that's our y coordinate. So for that dot right there, we would have 3 for the x-axis, which is right here. So 3, that's easy peasy. And then the y value is going to be about 2, so you can see about 2. So if you're in this upper right quadrant, that's not so big. That's not a big deal because these are both positive values. Where we need negative numbers though is particularly if we're down in one of these any other quadrant in the Cartesian grid is going to require negative numbers. So if I was to put that same dot down in, like, say here, for example, its x value is -3, so that's going to be -3 like this, and its y value on the y-axis, again, this is the y-axis, is going to be -2. So we need to have a way of representing these positive and negative numbers essentially if we're gonna do a Cartesian plot. And some examples of this, GPS coordinates, velocity fields. These are all examples of just some examples that use positive and negative numbers, right? So that's what this tutorial is going to be about today. So so let's get into this. So what now? Before we go too far into things, let's start with Google. So what I'm going to do is I'm going to bring up my little Google here. So if we look at the definition, if we just go to Wikipedia, like I did right here, and search on offset binary format, you'll see that it's also known as several other names. It's known as offset binary, as I'm talking about in this tutorial. It's also known as XSK, XSN, XSE, excess code, or even biased representation. These are all different ways that we represent offset binary. That you might hear people. So if you hear somebody say XSK, this is what they're talking about. And there's a lot to this. There's a lot to how it works, but it's actually very simple. So one of the formulas that we're going to be discussing in this tutorial today is a formula the offset formula. It's k equals 2 to the n minus 1. And the first time I seen this, I was like, what exactly is that? Like, what does that represent? So let's go ahead and take a look at this. So basically we have this offset number. So let's start with the formula first. So I'm going to write it up here. So we have this k. Oops. If I can get the right layer. There we go. So basically we have this k. Our formula. I'm going to write it down here. So this is our offset. So our k equals 2 to the nth minus 1. So where n is the number of bits in the word, so number of bits in the word. All right, now this, I promise this will make sense here in a second. So what do we mean? So for this example today, I'm going to use an 8-bit word. So we're going to use an 8-bit word like this. I'll just write this out here. So we got our 8-bit word. And again, just like my last several tutorials, we need to know the most to least, the least significant bit sides. We need to know so for the purpose of this tutorial, we're going to go most to least. So I'm going to say m most to least, like this, most to least. So that means this is going to be my least significant bit side over here, and this is going to be my most significant bit side. I'm giving myself some room today to work. All right, so there we go. All right, so we have our word. So what I'm going to do is I'm going to write my scale up here. So again, just like we did all along. So we got 1 over here, 2, 4. I'm making 8 bits here. 8, 16, 32, 64, And finally, on the last part, 128. Now you might be thinking, like, why are we using 8 bits? Simplicity. It's really about simplicity because I didn't want to get too carried away with this tutorial. And it's a byte boundary, so, I mean, computers work on bytes, so that's easy to work with. So basically we have this 8-bit word. So how do we figure out the offset? So what is our offset? So what I'm going to do is I have an 8-bit word, so I'm going to say, so to figure this out, we're going to say 2 to the n minus 1 is equivalent to 2 to the n. Now n is the number of bits. So in this case we have 8 bits. So we're going to say 8 minus 1, which is equivalent to 2 to the 7th power, which is equivalent to 128. So 128. So basically this number here in decimal is our offset value. That's our offset value. So now how does this work? Now this is, I promise this will make sense here in a second. So now what I'm going to do is I'm going to convert this 128 to this decimal 128 to a binary number. So this is easy. So using these 8 bits, we're going to turn the 128 position on. And just like we did in the previous tutorial, we're going to subtract 128 from, so because 128 fits into 128, we subtract it from it, and obviously that is going to zero out like so. So the rest of these are going to be zeroed out. So just like this, 0, 0, 0, 0, 0, 0, and 0. So this becomes our binary number here. So the offset value, I'm going to clean up shop here just a little bit. So I'll get rid of some of this stuff here. Oops. Never mind that, guys. Let me just back this up here just a second. Let's do that. Multiple layers going on here. All right, so all right, let's try this again. So what we have here is, I'm just going to erase this here just to make us a little bit more room here. So 128 is our offset value. So let's get rid of all this here. And this is an easy one to remember, so I can actually erase this. I'm going to leave my numbers there so I can come back, because we're going to do some more conversions here. So I'm going to come up here to the top, and for my offset, I'm going to put k for my offset, which is right here. So k equals 1 and then 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Making sure we have 8 bits here, which we do. And I'll put my little base 2 to it. Again, this is equivalent to 128 in decimal, which is our offset. That's our offset. So k is the offset. That's our offset. So we don't get confused here. So that's our offset. So the next thing we need to do, so now that we figured out our offset value, we need to figure out our actual value that we want to. So in this case, I'm going to do 2 values on this tutorial. So I'm going to start with a positive number, and then I'm going to start with I'm going to do a negative number after that. And we'll show you the difference between the two. And I think you're going to be surprised when you see the way this works. I know I was the first time. So the value in this case, what I'm going to use is positive 6 for this one. So we're going to start with a positive 6. So what I'm going to do is, I'm going to put v over here for my value. Now I'm going to make this number 6 happen. So again, I can easily do this by starting down here. This is why I left these numbers here. So 0, we're going to add the 4 plus 2 is 6. So these are both going to be turned on. And I'm going to pad the rest of these bits out so that we have 8 bits. Again, I can pad as much as I want, as long as it's padding to the most input side. It won't affect the actual value. So in this case, we're going to have 0, 0, 0, 0. Trying to keep these lined up as well. So we got 1, 1, and 0 binary. And that's 6. So that equals 6 in base 10. So just write that. Okay, so there we go. So now I'm going to erase this binary number here, just like we did, oops, without going too crazy there. Don't want to erase all the, try not to erase my hard work there. There we go, okay. All right, so now we got our k and our v. So now, where do we make the offset binary number? So all we do is, because this is a positive number, we're going to add these values together. So I'm going to come down here and we're going to add these together. So actually, let's do it here. So we're going to go like right here. So I'm just going to, so because this 6 is positive, we're going to add it to the previous number. So I'm going to come like this. Now for binary addition, so here's the rules. So binary addition, I'm going to write the rules down here. Binary addition. This might be something that I know we don't do it that often maybe, so I know I was kind of like, I had to look this up a while back because I don't do it every day. So in binary addition, 1 plus 1, we output basically 1, 0. So basically we're gonna do the 0 bit with a 1 carryover bit. So this is our carryover bit, which I'll show you that in a second. 1 plus 0 equals 1. 0 plus 1 equals 1, and then 0 plus 0 is nothing. 0. So, and an easy way to remember this is, here you have two 1s, and this is 1, 0 is 2 in binary. That represents decimal 2 in binary. So that's how I remember it anyway. So remember that. So I'm going to leave that here. So we're going to start on the least input side over here. 0 plus 0 is 0, so we're going to put a 0 down here. 0 plus 1 is 1, so we're going to put that here. 0 plus 1 is 1. 0 plus 0 is 0. So the zeros are all just easy peasy, 0, 0, 0. 1 plus 0 is 1. So basically this number right here becomes our value. That's our actual offset bar. Now what's happened here, and you may have noticed this, is if I was to put this number down here, so let's put that in our scale. So 1, 0, so we have 0, 0, 0, 0, 1, 1, 0. So now what I'm going to do is I'm going to actually, I'll leave this up here. I'm just going to add these up. So let's convert this number to decimal. So I'm going to take, so again, I'm going to add all the numbers up that have a 1 underneath them. So we have 128 plus 4 plus 2. So if we add all these up, what do we get? So we get 14. Yep, 14. Just making sure my math is right. I am tired today. Carry the 1. 2 plus 1 is 3. And then we get 134. So basically, this number here is equivalent to 134 in base 10. Huh. Okay, so now, so what has happened here actually? So this is where the cool part comes in, right? So if we were to actually, before I do that, let's do this. I'm going to change to my line tool here for just a sec. All right, let's make a line here. So I'm going to make a little number line down here at the bottom. I think this will make sense here in a sec. So I'm going to make a little line down here, just like this. And basically the way this works is the offset value is here in the middle at 128. So we'll say that's 128. That's our offset. This is our offset. So in this case, we had a positive value. So this thing, now because this is 8-bit value, this whole 8-bit value here, we basically have the ability to represent basically anything, a total of 256 possibilities, right? So basically everything from above 128 is all your positive values. Everything below 128 down to 0. So if this is 0, this will be all your negative numbers over here. So this is the negative side. Negative side. I'm going to leave this little scale up here. Negative side, and this is the positive side. Just like that. And again, this is going to go up to 255, just like this, 255, right? So where we fall into this, when we added that 6 to it, our actual value is over here at like 134. So we're at 134 right now, 134 on that scale. Cool, right? Isn't that pretty neat? I think it's neat. So what I'm going to do now, so that's the positive number. So now, so if I was going to read this, so let's just erase some of this here without taking out my number line. So now if I was going to, like, if I got this number, so if I received this number, if I was looking at this in a binary format, it's like, if all I see is these bits here and I know this is offset binary, like, what do I do with this exactly? So this is my binary value. Well, what we have here is all the way at this side here, this is what we call a sign bit. So that's our sign bit over here, sign bit. And the way offset binary works is, so in offset binary, a 1 equals positive numbers, and a 0 equals negative numbers, just like that right there. So in this case, that tells me this is a positive value. And if it's a positive number, all we do, if it's a positive number, we just read these bits as is. So this becomes positive, so that tells me it's positive, and then the rest of these values are just as is, so that's 6, so positive 6. So that's how we get positive 6 back from the number. Pretty cool, right? All right, so now let's take a look at this. So I may just make this smaller here just a little bit here. Oops. Trying to make my brush size just a little bit smaller here. All right, so because it's kind of big, and I don't want to raise. Okay, there. That's a little bit better. There we go. All right. So what I'm going to do now? So that's a positive number. So, oops. Now I realize I cut my screen off just a little bit here. All right, there we go. I think we're back to where. Sorry about that, guys. All right, so now we're back to our screen. I might just adjust this just a little tiny bit. Try to make this work for the recording. All right, so I'm going to erase some of this. I'm going to leave. So I'm going to get rid of my positive number. Now I'm going to leave this over here though, because I want to show it. So I'll leave the scale as is, and now we're going to do a negative number. So I'm going to change this a little bit here. So we're going to use some different rules this time. Everything is going to be basically the same. The only thing that's going to change is the value. So the value will change. So we're going to erase this all right here, just like so. There we go. Okay. So I'm going to go back to my pen tool over here. All right. So this time what we're going to do is we're going to do -6. So we're going to do -6. So just like this. So how do we do this? So same thing as before. Similar. In fact, one more thing I'm going to erase here is my positive value, because now we're going to subtract. So because this is a -6 number, I'm still using the same offset, and I'm going to subtract my value from this offset. So we're going to say, so in this case, I'm going to make that value happen. So I'm going to say 0. So 0, 0, 0, 0, 0, 1, 1, 0. And that's, again, that equals, now right now that equals 6. So that's 6 in base 10. So what I do here is I'm going to subtract these. Now to subtract in binary, so for binary subtraction, I'll write these rules up. A little bit of a different set of rules. So for binary subtraction, a little bit different. So with this one, what we're going to do is, most of these rules are pretty easy. There's only one that's a little bit weird. So 1 minus 1 equals 0, right? 1 minus 0 equals 1. 0 minus 0 equals 0. And the one that's weird a little bit is 0 minus 1. Like, what do we do with this? Well, what we do is we output a 1, but we also borrow 1. And this is going to make more sense here in a second. And we borrow 1 from the JSON. So basically what we do is, so in this case we have 0 minus 0 is 0. So we have 0, that's easy. 0 minus 1 is going to be, let's see here, so that's going to give us, so 0 minus 0 is 1. But then we got to borrow 1. So let's see, if we borrow 1 over here, so 1 minus 0 is 1. All right, so we got a 1. 1 minus 1 is, actually, let me do this a little bit a different way. Actually, I'm going to do it a little bit different here. So let's put the borrow 1 down here. I think this is the way I usually do it. I was trying a different way today. So 0 minus 1 is 1, and we borrow 1. 0 minus 1 is 1, and we borrow 1. So I'm going to put this one like right here in the middle. We're going to borrow 1 from this column. 1 minus 1 is 0. I got to do it the way I'm used to it. So that's kind of how I do it. So I'll show this again. So I think of it like this. So 0 minus 0. So 0 minus 0 is 0. 0 minus 1 is 1. And then we borrow 1. 0 minus 0 is 0. 0 minus 1 is 1. We borrow 1. 0 minus 0 is 0. 0 minus 1 is 1. And we borrow 1. I was trying to see if I could put them at the top, but I think for me, it might just be me. But I have to do it this way, guys. So if there's an easier way to do it, please let me know. If somebody does, definitely reach out to me. Let me know, because I'm always eager to learn new ways, easier ways to do these kind of things. So 0 minus 0 is 0. 0 minus 1 is 1. And we borrow 1 at the bottom. That's why I gave myself some room. 1 minus 0 is 1. 1 minus 1 is 0. So now again, that's our sign bit. So notice that for this negative number, this is now turned to a 0. And just like we did before, if I were to convert this, so if I write this over here, we got 0, we got 4 ones, so we got 1, 2, 3, 4, 0, 1, 0, 0, 1, 0. That's our number that we just converted. If we were to add those values up, that is where the cool part comes in. So if I go 64 plus 32 plus 16 plus 8 plus 2. So if we add all these values up, if we do that, if we just add all these up, so that's 8 plus 2 is 10, plus 2 is 16, plus 4 is 20, plus 2 is 22. So we got 22 here, so 22. So I'll put a carry the 2 over there. So 6 plus 3 is 9, plus 1 is 10, plus 2 is 12. So we get 122 in base 10. So that's what this number here is equivalent to. So 122 in base 10. So as you can see, we come down here. That would give us 122. So in the number scale, negative 6 is actually going to land over here. Positive 6 is actually going to add over here. So pretty cool, right? Pretty cool. So I know my idea of cool is probably different from everybody else's, but that's okay. So that's how this works. So now there's one other thing I'll show you. Now this is where it gets a little different. So that's just showing you, that's why it's called offset, is because we're offsetting from the middle point. So the 128, the k value, is the middle of this timeline. And it doesn't have to be 2 to the nth, doesn't have to be like they can use any number they want. So if an engineer, if they know what their what their highest and the smallest and largest possible values is supposed to be and what they're trying to do, they could use that. So they could use negative 55 if they want to. The offset can be 55. It doesn't have to be a power, is what I'm saying. So they could use whatever they want. They oftentimes use 2 to the nth, and they use like a power, like a 2 to the 8th power type thing, but they could use whatever they want for the offset. So keep that in mind. All right, so now where this is going to get, there's one more little thing to this, and then we'll stop the tutorial for today. And that is, I'm going to clean some of this up here. So now, what do we do with this number? So if that's our number, so I'm actually going to erase some of this here. I think we're good with this here. Yeah, so we're good with this right now. So we can erase all this. I'm giving myself a little bit more room on the whiteboard here. So we'll go back to our pencil. So I'm going to rewrite this number. So let's say we're looking at like a piece of data, and we get this number. So we get 0, we get four ones. So 1, 2, 3, 4, 0, 1, 0. And again, that's binary, so we'll put our base 2. So what exactly do we do with this number? Well, so as we said before, this is our sign bit, right? So this 0, going back to our rules, tells me this is a negative number. So I'm going to put my little sign bit right there. Now, so in offset binary, if it's a negative number, what we're then going to do is we're going to take the remaining bits, and we're going to convert or complement these bits or invert them. So we invert these bits. Invert. So if it's a positive number, we just treat them as is. Only if it's a negative number, we're going to invert the remaining bits in the word. So in this case, these bits become 1, 2, 3, 4 zeros. We get 1, 0, 1, something like this, right? So this becomes our number here. And then there's one more step. So we invert the remaining bits if it's negative, and we add 1 to this. So we add 1 down here, like so. And when we do this, 1 plus 1, go back to our addition. 1 plus 1 is a 0. We're going to have a carryover bit over here. 1 plus 0 is 1. And look at this. Like magic, we get back to what we started with, don't we? So pretty neat. I always think this is cool. So, and as you can see, this is 6 in base 10. So if we were to convert this over, if we put our scale over this, 1, 2, 4, 8, 16, 32, 64. Sorry, I know this is kind of hard to see probably. 4 plus 2 is 6. That's how we get that number. So pretty cool, right? Like, so that's the gist of offset binary. And you can see, like, if we were to actually add the positive and negative 6 together, we should get 0 if we were to add those together. And you can see that because if we really wanted to, we could technically, if we know what the decimal values are, we could just subtract 6 from this, and we could actually go backwards. So if we wanted to, if we know our offset's 128, we could just go back and convert, just subtract 6 from it. We gets us to 122 and convert that to a number, and that would get us to it as well. So pretty cool. I hope you guys found this tutorial interesting. I hope you learned a lot. Keep practicing the conversions. That's the only way you're going to get it. Keep on practicing, and I will see you on the next tutorial. The next tutorial after this is going to cover 2's complement, which is another form of representing positive and negative numbers. So until next time, toodles.